Now let's discuss the fifth problem. There is chef and tag. So in this problem, we have a tree rooted at the node 1, and there are k friends who want to reach k distinct leaf nodes, and the chef can be present at any of the leaf nodes. Right now, for every second, the chef will be moving towards the goal by 1, and then the chef can also climb up and move to the parent of its node in 1 second. Right now, whenever the chef and the people are present on the same node, the chef can tag the people, and we just need to find out the maximum number of people or the friends who can be tagged, right? So it's also given that chef cannot tag the same person twice, and once a friend reaches a leaf node, they cannot be tagged anymore, right? So it's just like the friends will be present at the root node, and they'll start to move towards their goals in each and every second, and chef will be present at one of the leaf nodes, and he'll be climbing up the tree. So whenever they meet, the chef can tag the people. So we just need to find out the maximum number of people who can be tagged. Right. So let's just take a tree and try to figure out what we have to find. So let's say this is a tree that we have. So we have here we have three number of leaf nodes, right? So the number of leaf will be the number of friends, right? Now these friends will be trying to go towards their goal, so that they'll be climbing down the tree, right? Now, what is the primary thing which we have to find out for this problem? So for every node, we just need to find out the time that it takes for the friends to reach that particular node. There is it's nothing but it's the time to reach from the root node to that particular node. So let me write them over here. So time to reach from root node, and it's nothing but it's the depth of that particular node, right? Or the level. And also we should know the time that our chef takes to go from a leaf node to that particular node. So time to reach node nd from leaf, and this is the least time that's possible. So let's say it's the minimum time. So for this particular node 2, we can go from 6 in 2 moves. Also we can go from any of the leaf nodes, say 4 and 5, in just one move. So we just want the minimum time that it takes for any of the leaf node to reach the node NT. And also we should be knowing for each and every node how many friends will arrive at that particular node. Right? So number of friends at each node. So when can a chef tag another person? So if at all he has already arrived at that particular node, then he can tag that particular person. Right? So if the first time, so let's say this is time 1, and the second is time 2. Right? So the chef time is time 2. So time 2 of that particular node is less than or equals to time 1 of that particular node. Then it means the chef can tag that person. So chef can tag the people who are arriving at that particular node. So how many people will arrive? So the answer is nothing but it will be the maximum answer, and then the number of friends who are arriving at that node. So let it be friends at ND. Right. So if these three values are calculated, then they can easily use this condition, and they can solve this, and we can calculate the maximum number of people who can be tagged. So how to calculate these values? So basically, I'll be just using depth first search to calculate this. So let me directly show my code so that you can easily understand this. So at first, I'm just constructing the adjacency list, and I'm invoking this DFS function. So the first element, there is a root node will be 1, and then its parent, let's say it's minus 1. Right now, inside this DFS function, I had calculated three things. One is the time from the root node, and then the time from the leaf node. There is a minimum time for the leaf node, and then the number of friends who are arriving at that particular node. Right. So let's start from here. So I'll be iterating through all the adjacent nodes for the node ND. Now, if at all it's not the parent node, so as it's a tree, I will not maintain a separate visited array and then check whether the current element is visited or not. So as it's a tree, then I can just maintain a parent, and if the current adjacent node is not a parent, then I can do these operations, right? So how to calculate the time from the root node or the distance from the root node? So for every node, it will be nothing but it will be the time from the root node of its parent plus one. So if the parent can be reached in 2 seconds, the child node or the adjacent node can be reached in 3 seconds. Right. So time from root of IT, that is the adjacent node, will be time from root of parent plus one. Now, at first, I'll be trying to calculate the answer for the child nodes, and then I'll come to the parent and update them. I'll be first invoking the DFS call, and after that, I'll be updating the time from leaf and the number of friends. Now, what is the logic for the number of friends? So, the leaf node will always have the number of friends as 1. There is only one friend can reach a particular node. Now, if at all we want to calculate for any intermediate node, then the number of friends who reach that node will be the sum of the friends of its children's node, right? So for 3, the child is 6, so this sum will be 1. For 2, the sum will be 1 plus 1 plus 1. As all the 3 nodes are its children node, so 2's number of friends will be just 3. And for 1, the adjacent node is just 2. So the number of friends will be the sum of all its adjacent nodes, which is 3. Right. So in this case, the sum will be nothing but it will be the number of friends of its children. So that will be assigned to the number of friends over here. Now, as far as time from the leaf node is concerned, so it's basically that the leaf node will always have the time of 0. Right. So it should be the least sum that is possible. So for the current node, the sum will be nothing but the time will be nothing but it will be the minimum time among the time from all of its children. So if the children's time is 2, then the parents time will be 3 from the leaf node. So as we want the minimum time to reach from any of the leaf node to the current node, so we'll be applying the minimum function over here. The base case, if all the degree of the node is 1, then it means that the node will be a leaf node, and also it should not be the root node, which is 1. So if the node is a leaf node, then the number of friends will automatically be 1. That is, only one friend can go to each of the leaf nodes, and the time from leaf node will obviously be 0. Right? So this is the base case that we have, and if these things are done, that is, if we have calculated all these 3 values, then we can apply the logic that I discussed in the first place. So if the time from the leaf was less than the time from the root node, then I'll be updating the maximum answer to the number of friends. This is how we can solve the 5th problem. That is the problem of chef and tab. So we'll first find the time from root, time from leaf, and the number of friends. Then I'll be updating my answer. So this is the easier way to solve this problem. So that's all about it for today. If you have any further queries or doubts, you may reach out to me in the comment section, or you may reach out to me in the social handles that are given below. And if you like this video, just hit the thumbs up button and subscribe to the channel so that it will be motivating for me to do further videos in the future. And with that being said, it's me Sundar signing off. So stay tuned for the next video and keep coding. Goodbye.